Okay, our lesson today is to be able to draw a dilation. Right? A dilation. In a dilation, the original figure and its image are similar. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is the scale factor of the dilation. A dilation is a type of transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. Right, remember, the scale factor is the ratio of the image side lengths to the original figure side lengths. That ratio is called the scale factor. When we use a rule to write a dilation, right, x comma y goes to the scale factor times x, comma, the scale factor times y. When that scale factor is greater than 1, the dilation is an enlargement. When the scale factor is greater than 0 but less than 1, the dilation is a reduction. All right? And when we draw a dilation, right, every point, if we have our origin as the center of dilation, right, if I draw a segment from the origin, both the original point and the image point, right, a segment from the origin should pass through each of the corresponding vertices. So I have this segment from the origin passing through A and A prime, right? If I take that same segment, right, and move it here, right, let's extend it. Right, if I take that same segment and extend it, it goes through B and B prime. Take that same segment from the origin and I extend it, goes through C and C prime. So we know that the dilation is using the origin as the center of dilation when you have a segment that passes through both the corresponding vertices of both the image and the new figure. All right. If you take a look here at this example, in example A we have a dilation because we have the figures are similar, meaning same shape, but they are not the same size. Whereas in example B, right, notice that the size has not changed. And if the size doesn't change, it's not a dilation, right? And that looks like that would be a translation because the figure slides, right? It's not turned, it's not flipped. So that'd be an example of a translation. If you look here at this example, right, example 1, looks like a reflection, right? And my line of reflection would be here, a vertical line. Whereas in example 2, it looks like a dilation because the figures are similar, right? Same shape, but not necessarily the same size. All right, so let's take a look at this first example here. The figure has vertices at 3, 8, 10, 6, and 8, 2. We want to graph the figure and its image after a dilation with a scale factor of 1/2. Right? Let's zoom this out a bit so we could see the whole thing. Right, so we zoom this out, looks like something like this. Now before we do anything, I like to get the coordinates of my image. So let's start with J prime. So if I start with J prime, right, J prime is going to be located where? Well, if my scale factor is 1/2, I take each of the values in my ordered pair and I multiply them by the scale factor. All right, so my scale factor is 1/2 here. So J prime, I take the scale factor, multiply 1/2 times 3, get 1.5. Take 1/2, multiply by 8, and I get 4. So if J is located at 3, 8, J prime is located at 1.5, 4. Right? I take each of the values, x and y, and multiply them by my scale factor. And because the scale factor is less than 1 but greater than 0, we're looking at a reduction. K prime, use my scale factor, 1/2 times 10 is 5, and 1/2 times 6 is 3. So K prime would be located at 5, 3. Then we have L prime. 1/2 of 8 is 4, 1/2 of 2 is 1, so L prime is located at 4, 1. We are asked to graph the figure and its image. So let's start with the figure. I'll do that in black. Right? So I'm going to start with 3, 8 over 3, up 8, 2, 4, 6, 8. There's point J located at 3, 8. Then we have 10 comma 6, 2, 4, 6, 8, 10, 2, 4, 6. All right, point K located at 10 comma 6, and then point L is at 8 comma 2, 2, 4, 6, 8 comma 2, and that's going to be point L. Let's connect those points using straight lines. Connect here, and I connect here. All right, so there's my original triangle, JKL. My new triangle, let's locate that. I'll do in red. J prime is located at 1.5. Well, 1.5 is in between 1 and 2, comma 4, 2, 4. So there's 1.5, comma 4. That's J prime. K prime is located at 5, comma 3. There's 5. There's 3. Right, that's K prime. And then L prime is located at 4, comma 1. There's 4, comma 1. There's L prime. Let's connect the points. So if I connect the points, all right, I want to do that, in a straight line. I need my fill effects. On style, I want red here. All right, and let's connect. So we'll go from here to here, here to here, and here to here. Now the figures should be similar, but once again I said check to see if it is a dilation with the origin as the center of dilation. So I can take a ruler and I line up my ruler with each vertice, and I see my original vertice is J, my image vertice is J prime, right? And both the image and the original are on a segment that comes from the origin. Let's look at K and K prime. Once again, I take my ruler and I could see that both K and K prime are on a segment. Each of those corresponding vertices are on a segment that passes from the origin. And look at L and L prime. Once again, L and L prime are on a segment from the origin, the corresponding vertices. So I know that that is a dilation. All right. So there's a scale factor of 1/2, and we have a reduction. Make sure to use your prime notation to denote the original and the image. Let's take a look at the next example. A figure has vertices at -1, 1, 1, 1, 2, -1, and -1 and -1. Graph the figure and the image of the figure after a dilation with a scale factor of 3. Well, let's write our rule. We talked about it, in the introduction. Right, x comma y goes to, if my scale factor is 3, it's going to be 3 times x, comma, and 3 times y. So that's what my rule would look like. So we're doing an enlargement because we're using a scale factor that's greater than 1. Okay, let's start with the original figure. F is at -1, 1. Well, here's -1, 1. There's point F. G is at 1, 1. Over 1 up 1. That's going to be G. H is at 2, -1. Over 2 down 1. That's going to be at H. And I is at -1, -1. Right, there's point, there's point I. Let's connect the points. Segment here, segment here, segment here. A little sloppy with those segments, right? Let's try to fix that a bit. Right, let's fix that a little bit. That should be straight up and down. This one, let's extend that a little bit. Okay, that's a little better. And then now, let's fix that. It should be here, and extend that one a little bit. Okay. Now, in red, we'll do the image. We didn't do our image yet, so let's get our image values. Right, F prime, using a scale factor of 3, we take each of the values for x and y, we multiply by our scale factor of 3. -1 times 3 is -3. +1 times 3 is 3. So F prime would be located at -3, 3. We have G prime. We take each of the values x and y, multiply by a scale factor of 3. 1 times 3 is 3, and 1 times 3 is 3. Then we have H prime. H prime, 2, -1. We multiply each of those values for x and y by our scale factor of 3. So 2 times 3 is 6. -1 times 3 is going to be -3. Then of course we have I prime. Negative 1 times 3 is negative 3. Negative 1 times 3 is negative 3. Let's graph the image at negative 3, comma 3. It's going to be f prime. Then we have g prime is located at 3, comma 3. That's going to be g prime. We have h prime, which is located at 6, 2, 4, 6, comma negative 3. It's going to be our h prime. And let's see what else we have. We have I prime, which is located at negative 3, comma negative 3. There's our I prime. Let's connect those points. All right, let's use red again. Fill effects, line style red. Okay, connect our points. So we go here, and here, and here. Now, it certainly looks like an enlargement, but once again, let's check using our ruler, because each of the corresponding vertices should fall on a straight line drawn from the origin. So watch what we do here. So if you have your ruler, start at the origin, and G prime fall on a segment. H and H prime fall on a segment from the origin. I and I prime, right, lie on a segment from the origin, and we have F and F prime lie on a segment from the origin. So you want to check with your ruler. It's very simple, and then you know that your dilation has used the origin as the center of dilation, and your dilated figure is correct. All right. Okay, let's look at our next example. Lucas wants to enlarge a 3 by 5 photo to a 7.5 by 12.5 photo. What is the scale factor of the dilation? Well, we talked about scale factor being the ratio of the corresponding sides. So let's just sketch that photo real quick. Right, 3 by 5. And we want to enlarge it to something that is 7.5, right, by 12.5. Now, if we're talking about the corresponding sides, 3 and 7.5 are corresponding sides, 12.5 and 5 are corresponding sides. Your scale factor is the ratio of the image to the original. All right, so we use the corresponding sides. So if I take my image, which is the 7.5, the original is the 3, I can use my 7.5 over 3 to find my scale factor, right? And what is 7.5 divided by 3? Well, that's 2.5. Right? Or I could have used my other corresponding sides. I could have used my 12.5 to 5, 12.5 to 5, and 12.5 to 5 would also give you a scale factor of 2.5. So by using the ratio of the corresponding sides of the image to the original, we're able to find our scale factor. Okay. Let's get back to dilations, right? This next slide is just kind of a summary of what we've done so far, right? So let's continue. It says a figure has vertices at negative 2 comma 4, 1 comma 4, negative 3 and negative 1, and 3 and negative 1. Find the coordinates of the figure after a dilation with a scale factor of 2. Now it doesn't ask us to draw it, but I always like to draw it just so that we can see, right, if the if the figures are similar, and if the corresponding vertices lie on a segment that comes from the origin, if we're using the origin as our center of dilation, which, all the dilations that we're going to do in class and for homework, we will be using the origin as our center of dilation. So let's start with a rule, because I always like to write the rule. So x comma y goes to, right, 2 times x and 2 times y. Let's start with w prime. Right, so we have 2 times x, so it's going to be negative 4. 2 times y, that's going to be 8. So if w is at negative 2 and 4, w prime is at negative 4 and 8. X prime is going to be located at 2 times 1 is 2. 4 times 2 is 8, so 2 comma 8. Then we have y prime, which would be located at negative 3 times 2 is negative 6. Negative 1 times 2 is going to be negative 2. Then, of course, we have z prime, which is going to be located at 3 times 2 is 6. Negative 1 times 2 is going to be negative 2. All right, but let's draw it and make sure that our dilations are correct. Right, so let's start with the original. Negative 2 and 4. It's going to be W. Then we have 1 and 4. That's going to be X. We have Y's at negative 3, negative 1. It's going to be our Y. And Z is going to be at 3 and negative 1. Right, there's our Z. All right, connect our points. Looks like we're here, here. All right, connect our points with straight lines. That looks good. And then let's look at our image. In red, W prime is at negative 4, 2, 4, 6, 8. There's our W prime. X prime is at 2, 8 over 2 up, 2, 4, 6, 8. That's at X prime. We have Y prime is at negative 6 and negative 2. There's our Y prime. And then we have Z prime is at 6 and negative 2. 2, 4, 6. 6 and negative 2. There's our Z prime. Let's connect our points. All right. Let's do it in red. From here to here. Here to here. And right, make them nice and neat with the rulers, and it looks like the figures are similar. All right, but let's double check. Right, we want to draw a line from the origin through each of the corresponding vertices, and the corresponding vertices should line a line. So we can do that quickly with the ruler. Just check. X and X prime look good. Z and Z prime look good. Y and Y prime look good. W and W prime look good, right? Because the corresponding points, right? Here's W prime, right? And they lie on a line that comes from the segment, so we know that the center of dilation is our origin. Well, a few more. All right, this one I didn't include a graph because we're just going to use the formula. It says a triangle has vertices of 0, 0, 8, 0, and 3, negative 2. Find the coordinates of the triangle after a dilation with a scale factor of 4. So if we're writing a rule, x comma y goes to, it's going to be 4 times x and 4 times y because we're using a scale factor of 4. That's an enlargement. A prime then would be 4 times 0 is 0. 0 times 0 is 0. B prime would be located at 8 times 4 is 32. 0, 0 is 0. And then C prime would be located at 3 times 4 is 12, and negative 2 times 4 is going to be negative 8. So these would be your coordinates of A, B, and C, or of A prime, B prime, and C prime after dilation with a scale factor of 4. Okay. This next one asks us to, let's see, make this a little smaller. All right, it says to draw the image of rectangle WXYZ after a dilation with a scale factor of 0.5. Identify the type of dilation. Well, if we're identifying the type of dilation, that's going to be easy. It's a reduction, and it's a reduction because our scale factor is greater than 0 but less than 1. Right, so let's start with our rule. X comma y goes to 0.5 times x, comma 0.5 times y. Or you could have used 1/2 x, 1/2 y. That would have been fine too. Right. Let's start with our image because it does ask us to draw the original. So it does. So let's draw the original. W is at negative 4 and negative 6. There's negative 4, 2, 4, 6. Right. That's going to be W. Then we have negative 4 and 8. Negative 4, 2, 4, 6, 8. There's negative 4 and 8. That's X. Then we have 4, 8. There's 2, 4, 2, 4, 6, 8. There's 4, 8. That's Y. And Z is at 4, negative 6. There's our Z. Connect our points. We're here. Here. Right. We're here. And we are here. The image after dilation. Well, let's use our rule. W prime is located at what? Half of negative 4 is negative 2. Half of negative 6 would be negative 3. Then we have x prime would be located, half of negative 4 is negative 2, half of 8 is 4. Y prime, half of 4 is 2, half of 8 is 4. And z prime, half of 4 is 2, half of negative 6 is negative 3. Let's graph these ordered pairs. So negative 2 and negative 3, negative 2, negative 3, that's going to be here. That's our w prime. X prime is negative 2 and 4. There's our x prime. Y prime is at 2 and 4. There's our y prime. And z prime is at 2 and negative 3. That's going to be here. There's our z prime. Let's connect the points. Alright, let's connect the points. We're here. Here. Alright, use straight lines, please. Alright, this one's a little crooked. I want to fix that. Good. Okay. And now, it looks like it is the same shape. Figures look similar, but let's check it. Right, so straight line from the origin, y and y prime, z and z prime line the same line, w and w prime, and of course x and x prime line a segment. So it looks like we have a good dilation, a reduction, using a scale factor 0.5 with the origin as our center of dilation. Okay. Now finally, we're going to, if we have to use more than one transformation, right? So let's finish with that. The vertices of the trapezoid are at negative 2, negative 1, negative 1, comma 1, 0, 1, and 0, negative 1. We want to dilate the trapezoid with respect to the origin using a scale factor of 2, then translate it 6 units to the right and 2 units up, what are the coordinates of the image? Okay. Well, let's start with two rules, right? Because we have two separate dilations here. Or, I'm sorry, two separate transformations. One being a dilation, second being a translation. So our first rule, let's start with that, x comma y. Right, that's going to go to. All right, now we're talking about a dilation using a scale factor of 2. So it's 2 times x, 2 times y. And then our second rule, x comma y, goes to, right, translate it 6 to the right, so that's going to be x plus 6, comma, 2 units up, it's going to be y plus 2. So those are our two rules, all right? So if I want to use the two rules to come up with my ordered pairs, let's start with a prime. A prime is going to be located, let's see, if we start at negative 2, first we have to double it, so it's going to be negative 4, and then we have to add 6. Negative 4 plus 6. It's going to be positive 2. Then I look at my y value. It's at negative 1. First I have to double it. That's going to be negative 2. Then we add 2. Negative 2 and 2 is going to be 0. So a prime, after the dilation and the translation, is going to be located at 2 comma 0. Let's look at b prime. B prime starts at negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 6 should be positive 4. Comma, 1 times 2 is 2. 2 plus 2 is 4. So b prime would be located at 4 comma 4. Then we have c prime. 0 times 2 is 0. 0 plus 6 is going to be 6. Then your y value, 1 times 2 is 2. 2 plus 2 is 4. And then finally d prime. That's d prime. 0 times 2 is 2. 2 plus, oh, that was bad. 0 times 2 is 0. 0 plus 6 is 6. And then we have negative 1 times 2 is negative 2. Negative 2 plus 2 is 0. So those are the coordinates of our image. All right. So let's draw the trapezoid. And let's see, if we draw the trapezoid, let's do the original first. So the original is at negative 2, negative 1. There's negative 2, negative 1. And I want to do this in black. All right, negative 2 and negative 1. That's going to be A. B is at negative 1, comma 1. There's B. And then C is 0, comma 1. There's C. And D is at 0, negative 1. Right, there's D. So it's rather small, but that looks good. It's here. Then we have here. Then I have, that should be going straight down. So let's fix that. Gotta fix that. Right, that should be here. Then even this one, I want to fix a little bit. That should be straight. And then we have a segment here. So there's our original. Now the image, it's going to be enlarged and translated. So 2 comma 0 should be here. It's my A prime. B prime is located 4 comma 4 over 4 up 4. There's my B prime. C prime is 6 comma 4, 2 4 6 comma 4. There's your C prime. D prime is 6 comma 0, 2 4 6 comma 0. There's your D prime. All right, so the figure should be, it should be translated, it should be enlarged, figure should be similar, and it looks something like that. All right, so that's the lesson today. Just remember, when you draw dilations, we simply use the scale factor to multiply both the x value and the y value of the ordered pair. Just make sure that you understand that an enlargement is when you're using a scale factor that's greater than 1. A reduction is when we're using a scale factor that's greater than 0 but less than 1. Finally, to find the scale factor, we use the ratio of the corresponding sides of the image to the original. All right, I hope that's been helpful, and we'll see you soon.